On to another geometry lecture. This time is 12-4, angle measures and segment lengths. If you follow along in our book, it's page 790. Okay. So, no new vocabulary words up in there. We've had angles before, we've had segments, and then measures and lengths, obviously, just the values of them. So, we just get right into a theorem. So, theorem 12-13. We've had a ton of theorems in this section. Well, we're going to need a circle. Well, and theorem 12-13 says, let's see, I need this, and then I'm going to go with angle 1. I need to label these, so I get A, B, C, D. Okay. It says that the measure of an angle is measure of an angle formed by intersecting lines inside the circle. So I have intersecting lines AC and BD inside the circle is half the sum of the intercepted arcs. Okay. I'm just going to change this color here. So what that means is the measurement of angle 1, because it's an angle formed on the inside of intersecting lines, is half of the sum, so it equals half. Sum meaning I have to add, and my intercepted arcs would be AB and DC. So half of arc AB plus arc DC. Now we get right into theorem 12-14, which we're going to need a new circle. Theorem 12-14 says that if I have now on the outside, so let's see, angle, again we'll say angle 1. We need some labels, so let's go with M, A, T, H for math. Okay, so theorem 12-14 looks like this, and it says, what's the official start? The measure of an angle, so the measure of an angle formed by intersecting lines the difference of the intercepted arcs. Okay. So the key things to note are outside the circle, which this is clearly outside the circle where our intersecting lines, well, intersect. And the big thing is the difference. So the first one, so theorem 1213 is inside, and it's the sum. 1214 is outside, and the difference of those arcs. So if I were to write an equation for this particular example, the measurement of angle 1 equals, again, half, so 1/2, and then it's the difference of those arcs. Now, my arcs would naturally be MA and TH. Now, with these difference and subtraction, order does matter. So be sure to include that bigger arc first. We don't want to have a negative angle. Okay, so I get the arc of TH minus the arc of MA. Okay. Now on to example 1. Do I have a little for this? Yeah, find angle measures. So, I have okay, so let's see. 2 circles. I have, let's see. X. This looks like a 90, sure. And then this looks pretty small. Let's go with 24. Let's see. If I know that this is 40 and this looks, let's go with 160. Okay. So, just ballparking ideas there. So, we can first look at our first one. In this one, I need to look at where my intersection is taking place. In this case, my intersection is on the inside. So now it's going to be half the sum. So I get 1/2, or x equals 1/2 the sum, so 90 plus 24. 90 plus 24 would be 114. So I get 114 times 1/2. So let's see, 114 divided by 2 would be 57. So x equals 57 degrees. Over here, if I know that this tiny little thing is 40, this is 160, well, the missing piece is right here. So again, my intersection occurs where? In this case, outside. So my 40, because that's my angle, is going to equal 1/2 the difference of those. So I get 160 minus x, because it has to be the difference. Okay, now this one's a little trickier, just because my variable's on this side. So the first thing I can possibly do is try to get rid of my 1/2. So what can I multiply by that would make that 1/2 a 1 and cancel it out? That would be the reciprocal, which would be 2. So if I multiply one side of an equal sign by 2, what do I do to the other side? Well, naturally I have to also multiply by 2. So multiplying each side by 2, crosses those off, I get 40 times 2, which is 80. So I get 80 equals 160 minus x. Now I can subtract by 160, subtract by 160. So I get 80 minus 160, which would be negative 80, equals negative x. Now, how can I get x by itself? I could divide by a negative, divide by negative 1, divide by negative 1. So in this case, x equals 80, which we could argue is clearly not drawn to scale, but again, imperfect drawing and less precise markers might just go and just ballpark it. Let's get trickier on that one. Okay. So, example 2. Satellite, how do I spell satellite? 2 L's maybe? Ow. Okay, so let's say we have the Earth and everyone's happy. Except for right now with all coronavirus, everyone's freaking out. So maybe okay, so on the Earth, let's say we have our satellite way out here. Yeah, I'm just over it. It's gonna be, we're gonna pretend. And I want to know from my satellite if I form a 17.5 degree angle there, what kind of arc or shadow would I leave? So this one's even trickier, because again, my 17.5 would be the difference of the two arcs I've intercepted. However, it doesn't seem like I've intercepted two arcs, but I actually have. My first arc is really easy to see. It's this x piece. That's my first arc. Now, because it's in such a way that I don't have it gutting through, I don't have a second arc created, the other arc is just everything that's left. So my second arc is actually this piece. Okay. So I know that 17.5 is going to equal, again, half the difference. Because I know it's the difference because my satellite is, again, not inside the Earth's core, it's way out there floating. The tricky part is this part's pretty easy. My small arc is going to be x. Okay. But what's a little difficult to wrap my head around is what my big arc is. So here's the thing. How many degrees are in a total circle? Well, if a total circle has 360, but this part is x, what has to be left? Well, if that chunk was, let's say, 45, I could just subtract it. I could do 360 minus 45, and I know the rest would have to be 315. So the same logic would apply. I know the entire circle is 360, and if that chunk is just x, all that's left in red would be the idea of 360 minus x. So I can plug that in, 360 minus x. Okay. And I'm going to put it in brackets just so for right now. It doesn't need to be, it doesn't mean to be anything right there. So now I get this kind of goofy stuff. Well, order of operations said I should always do my parentheses first. So I get 360 minus x minus x. Well, thankfully I have some like terms that I can combine. I can combine a negative x and a negative x. So my parenthetical expression is now 360 minus 2x. And I still have my 1/2. And I also have my 17.5 out there. I haven't done anything with it. Okay, now we're in familiar territory. How can I get rid of my 1/2? Well, again, I can multiply by the reciprocal. So multiply by 2, cross it off, multiply by 2. 17.5 times 2 would be 35. So I get 35 equals 360 minus 2x. And then again, now it's just algebra. I've got to isolate my variable. So the farthest thing away from my variable is on its side is the 360. So minus 360 minus 360. 35 minus 360 would be negative 325 equals negative 2x. And then I can just divide by negative 2 by my negative 2. Well, let's see. 325, 2, 1, 2, 6, 2. 162.5 will be my answer. Okay. That one was a little trickier, just because I had to do some figuring. Okay, next we get theorem 12-5. So those last two ones we've been doing with angle measures, this one's all going to be about those segment lengths. Okay, so let's see. For a given, you're going to need space for 3 circles here for this theorem. So make sure you plan accordingly with your notes. For a given point in a circle, the product of the length of segments from the point to the circle is constant. Okay. Now that sounds like a whole lot of stuff going on, but we can really break it down into 3 individual cases. So, we're going to do that. So the first case is my lines intersect inside the circle. Okay. And let's say I have different values. Let's say x, y, where x just goes from the edge to the intersection, and y is also from the edge to the intersection. And then I also have a and b. Again, edge to intersection, edge to intersection. Okay. Well, the key piece here is the product and the idea that they're constant. So product means multiply. So A times B. And then for my blue, I would get X times Y. Because again, that's all a product means. Now the big thing is we all have to consider that they're constant. So constant means same, or the same value. So they are equivalent expressions. Okay, that'd be one case. Another case would be, let's say I have my intersection outside the circle, and my things go through. So let's see, I got that. And I'm going to have, let's see, I've already used A and B and X and Y, so let's say we have N and P, where N is from my point to the edge of the circle, and P is from the edge of my circle to the edge of my circle. numbers, so let's do R and S. Again, where R is from my point to the edge of my circle, and S is from the edge of my circle to the edge of my circle. Now this one shares a little bit different of a relationship. The products are still going to be the same, except one little wrinkle. When it is outside the circle, so outside circle, you have to also multiply the outside value times the entire segment. So what that means is the entire segment, well, for my pink, my outside value would be R, so I would get R times the entire segment. The entire segment would be R plus S. So R plus S on the inside. For my light blue, I would get N times, well, parentheses, N plus P. And then I could just say equal. Okay. Now the third case is a variation of this one and stuff we've talked about in previous lessons with like tangent and stuff like that. So, my intersection's outside the circle, but one of my lines is tangent. So all it does, it doesn't go through the circle, it just hits it at one point value. So in case, let's just say that's T. Well, my other one does go through, so WB. Okay, so this orange one functions the exact same way as my blue and pink one did over there. So W times the entire length, so W plus V. And then it's going to equal. And then over here, my blue one still works the same way following this rule. The outside value, so in this case T, has to be multiplied times the entire length of the line. However, the entire length of the line is just T. So I get T times T, or T squared. So those are the three types of cases that can happen for theorem 12-5. So if they're inside the circle, we just get this part times this part has to equal this part times this part. If they are outside the circle, we have to take the outside value times the whole length of our line. So R times R plus S, N times N plus P. And then of course, the last one is if the whole part of the line is just that little segment, we just get it squared. Okay. Let's do some example problems. Let's see. Example 3, segment lengths. And it looks like I got two problems, so we need two circles. Let's just do three problems. Let's just do one of each case. Okay, so I have six, 7, 8, and Y. X, 8, 16, and then I'm going to need to pick some values in here that'll 6, 3, and z. Okay. So let's start with our far left one. So again, it's inside the circle, so I can just multiply the values that are in the same segment. So I get 6 times 4, 6 times 4 equals 3 times z. So 6 times 4 is 24, 3 times z, 3z, and then I can just divide by 3, so z has to have a length of 8 units. Okay. Well, I got 8 in all 3 of them, that's kind of crazy. Okay, moving on to the next one. Let's see. I have an outside segment, I get 6 times the entire value, so 6 times 6 plus 8. Now again, be sure to do the parentheses first, 6 plus 8 being 14, and 6 times 14, well I believe it'll be 84, let me just double check. 6 times 14, yep, 84. And on my other side, I get 7 times 7 plus y. 7 times 7 plus y. Now in this case, I can't do anything with the parenthetical expression because I would just get stuck because I can't combine like terms. So I can distribute my 7. 7 times 7 gives me 49. 7 times 7y gives me 7y. And again, they have to equal each other. Now just algebra says, what's the farthest thing on my y side from it? Would be the 49. So to isolate, subtract my 49. Subtract 49. 84 minus 49. Double check, 35. So 35 equals 7y. Then divide by 7, y equals 5. And last but not least, one like this. Well, again, I get my outside value 8 times the entire segment length, 8 plus 16. 8 plus 16 is 24. 8 times 24. Again, I believe it would be, let's see, 160 plus 32, 192, but let me double check. Yep, 192. Now my other one, I get x times the whole segment. Well, again, it's just going to be x squared. So then to get x by itself, how do I undo that square? Well, I have to square root. So square root of 192. Square root of 192, which is x is roughly, or estimating about 13.9. Okay. So 8, 5, and roughly 13.9, or just the square root of 192. That's all the type of problems from that section. Thank you for watching, and I hope your homework goes well. If you have any questions, feel free to shoot me an email. Thank you.